Hey guys, welcome to a summary of what you need to know for a calculus exam on Tuesday. So in this video, I'm going to be covering all the basic skills that you need to know to be able to do well on the calculus exam. And for this, I'm going to be walking over some of the typical exam questions and how you'll be able to answer these exam questions. Okay, so basically what the different skills that are really required. So first thing you need to be able to do is be able to find the gradient at a specific point, okay? So for example, the question give you a function, and they're going to give you an x point, and they want you to find the gradient at that x point. For these types of questions, okay, the first thing you got to do is differentiate, okay? So you want to find f dash of x. So f dash of x, okay, that equals 2. You differentiate the function, that's just the coefficient multiplied by the power, and then you take the power down by 1. So that'll become 3x squared plus 10x. So at the point of x equals to 3, so that all you have to do now is substitute x equals to 3. So f of 3, that just means I'm substituting 3 into the equation, equals to 3 squared plus 30. And that should give you the answer of 57. And that's all you need to do for a question like this. So basically, when it says you to find the gradient of the graph of the point, it's just basically differentiate and make it equal to the x point. Alright. So the next one is going to be finding given a gradient to find the x point. So basically, just doing the reverse of what we just did. Roll it. So next we need is to find the gradient, to find a point when given a gradient. So a perfect example of this question is find the coordinates of the point of the curve y equals to 4 divided by x squared, where the gradient is 1. For these questions, okay, we need to differentiate, and then this time instead of making the x point equal, this time we're just going to substitute the gradient equals to 1 and solve for that x point. So basically, to find the coordinates, okay, so the key words here. So coordinates, that means the x and the y point, okay? So that's not only the x point, but the y point as well. So in order to find the coordinates, we're going to be substituting our x point into our original function. But the first thing we need to do is to find the x point where the gradient is 1. So first thing we're going to do is differentiate. But first, we need to rewrite this equation as 4 to the power 4x to the power something, because we don't like fractions. So we're going to say that y equals to 4x to the power of negative 2. So therefore, dy over dx will be equal to. So then you add 1 to the power, and then sorry, not add 1 to the power. You multiply by the power, and then you take away 1. Sorry. So then dy over dx, you should get negative 8 x to the power of negative 3. So you can rewrite that one as negative 8 over x cubed, and that equals to dy over dx. Alright, so now I need to find when the gradient is 1. So now we're going to substitute our dy equals to dx equals to 1. So 1 equals to negative 8 over x cubed. If we move the x cubed to the other side, we'll get x cubed equals to negative 8. And via on your calculator, you should see that x would be equal to negative 2. Okay, you're not quite done yet because it says find the coordinates of the point. So now we need to substitute our negative 2 back into our equation. So y equals to 4 divided by negative 2 squared, which is 4. Negative number squared is positive, so that should give us 1. So our final point would be negative 2, 1. And that's a typical question you're going to come across. Okay, so finding a point when given a gradient. Alright, so the next skill we're looking at, okay, is going to be finding the tangent when given a function and given a point. Roll it. Hey guys, so I'm going to be covering how to find the equation of a tangent at a point with an example question. So in order to find a tangent, okay, so you need to note down the equation of a straight line is y equals to mx plus c, where m is our gradient and c is our y-intercept. Alright, so you notice you can find the gradient with our gradient function, so the derivative of our function. And we have our x point, which is x equals to 3. So basically, if we substitute our x point into our function, into our gradient function, we should be able to get our gradient for the tangent. And that's exactly what we're going to do. So we're going to write our dy over dx equals to 1.2x squared plus 0.8x minus 4.8. Right, we're going to substitute 3 into the equation. So dy over dx equals to 1.23 squared plus 0.3 times 3 minus 4.8. should get your answer as 8.4. So now you know that 8.4 is your gradient. So now I can rewrite your equation as y equals to 8.4x plus of c. So you still need to find your c value and you have a y value. In some questions, they'll automatically already give you the y value, but for this specific question, they have not given you the y value. So you need to manually find that y value yourself. How are we going to do that? We're going to substitute our x value back into our function. The reason for this is because for a tangent to a graph, the tangent is touching the function. That means when x equals to 3, the tangent is equal to our y curve. That means if we substitute x equals to 3 into our y equation, we will theoretically get the correct y point for our tangent point as well, because they're both touching at that point. So therefore, we're going to substitute 3 into our y equation. So y equals to 0.4 times the 3 cubed plus 0.4 times the 3 squared minus 4.8 times the 3. And the answer should come out to be as 0. So now you know that when x equals to 3, y equals to 0. And now all we have to do is solve. 0 equals to 8.4 times the 3 plus c. So therefore, 0 equals to, 0 equals to 25.5 plus c. Therefore, c equals to negative 25.2. So therefore, you can write your final equation as y equals to 8.4x minus 25.2. And that would be your final answer. Alright, so next I'll be covering how to find a local maximum and minimum given a y function. Roll it. Alright, so to find a local minimum or local maximum, you know that when a local minimum or a local maximum, that's when the gradient is equal to 0. And therefore, we can use our gradient function in order and substitute that equals to 0 in order to find our x points when our turning points are. And then we're going to be using the second derivative test to find which one is our minimum and which one is the maximum. For most questions, you need to prove using the second derivative test. In this question, the gradient of a curve is given by dy over dx equals to 6x squared minus 12x. The y-coordinate of the minimum turning point of the curve is 10. Find the equation of the curve. Alright, so it tells you the y-coordinate of the minimum turning point, okay? So in order to find our turning points, okay, that's the most important thing we have to do is to find our turning points of our graph, okay? For right now, we have our gradient function, and you know that when is the turning point, the gradient is 0. So therefore, you can substitute, you can say that dy over dx equals to 0. So 6x squared minus 12x equals to 0. Alright, so I'm going to solve this equation. So you can take the 6x out, so that becomes 6x bracket x minus 2 equals to 0. Alright, so now you can clearly see that x equals to 0 or x equals to 2. But we have a slight problem because it says the y-coordinate of the minimum turning point. However, we have two turning points equals to x equals to 0 and x equals to 2. So now we need to use our second derivative test in order to find our which one is the minimum and which one is the maximum. So we need to find our second derivative. Alright, so this abbreviation I'm writing down here is just another way of saying the second derivative. If you don't like this way, you can simply say f double dash of x or f double dash. Okay, there's so many ways to write it, but personally, it really doesn't matter just which way you would prefer to write it. So our second derivative would equal to 12x minus 12. So now if we substitute x equals to 0, for example, so that would be 12 times of 0 minus 12, and that gives us negative 12. This is negative, so therefore this would be our maximum turning point, okay? So when the second derivative is negative, then it's a maximum. If the second derivative is positive, then it's a minimum. And if we say d squared y over dx squared of 12 times of 2 minus 12, this gives us positive 12. This is positive, therefore this is a minimum. Alright, so now we know which one is the maximum, which one is the minimum. So now you know that when x equals to 2, y equals to 10. And now we can use that to find our equation of the curve. So now we can say that y equals to, now you integrate. So integrate, you add 1 to the power and divide by the new power. So 6x squared becomes 2x to the power 3. And 12x becomes, minus 6x squared plus of c. So now I know when x equals to 2, y equals to 10. So 10 equals to 2 times of 2 cubed minus 6 times of 2 squared plus c. So we just need to do a bit of calculator work here. So 2 cubed is 2 cubed, sorry. 2 cubed times of 2 minus 6 times. So that gives us negative 8 plus c equals to 10. So therefore c equals to 18. So therefore our final equation is y equals to 2x cubed minus 6x squared plus of 18. And that's a way we can solve using local maximum and minimums. Alright, so for the next part, I'm going to be covering a rate of change question. Roll it. Alright, for this next part, we're going to be covering rate of change questions. So normally in NCAA exams, just normally, not always, but rate of change questions are normally only available for achieved and merit grades. But occasionally they do give us an excellence one, but it's not very common at all. So in this one, I'm just going to be covering an easy achieved question level for rate of change. So water is being added to a trough. The volume V liters of water in the trough is given by V equals to 9H plus 0.025H squared, where H is the depth of water in centimeters. Find the rate of change of the volume with respect to H when the water has a depth of 15 centimeters. So basically, this is just an application type question for find the gradient at a point of x equals to something. It's just application type. So we're going to follow the exact same procedure. So we're going to find our gradient function v dash of h that equals to 9 plus of 0.05h. So basically, we just need to substitute our h equals to 15 centimeters to find the rate of change. So v dash of 15 equals to 9 plus of 0.05 times 15. The answer should come out to be 9.75. Alright, so the only difference between this question, rate of change question, and a gradient question is that for a rate of change question, you do need to add a unit. So you know the question says find the rate of change of the volume. So volume changing with respect to h. So basically, volume is measured in centimeters cubed, and h is measured in centimeters. So therefore, unit is just simply going to be centimeters cubed over centimeters. So something changing with respect to the other one. So the one that's changing is the one that comes on top, and the one that's with respect to is at the bottom. Alright, just remember the unit. Okay, it's very important. Okay, if you lag behind the unit, sometimes you can get marked down, and it feels bad. Okay. Alright, so for the next part of the video, I'm going to be covering some application type questions for the maximum and minimums for application type. So basically, just maximum and minimums, but instead of f of x, it's going to be, for example, like a box or just like real life application. Roll it. Alright, so here is an application type question for our maximum and minimums. So it says here, the daily profit in thousands of dollars from a sales of a chemical is given by P of x equals to x cubed minus 12x squared plus 36x plus 3 for x is between 8 and 1. That's pretty important just to note. Where x is the number of tons of chemicals sold daily. What is the minimum daily profit? Alright, so now we're going to use our logic of maximums and minimums in order to find our minimum daily profit. So it gives us our daily profit, P of x, but in order to find a minimum, we need to find the gradient function and make that gradient equals to 0. It's basically the same steps. So we're going to differentiate our function. So that becomes P dash of x equals to 3x squared minus 24x plus 36. And now we have our gradient function, we'll just make it equal to 0. 0 equals to 3x squared minus 24x plus 36. If we take the 3 out, it should give us a much easier question, so that becomes that. So this will become 3 times of x minus 6, x minus 2. And that equals to 0. So therefore, our x values are going to be x equals to 6 or x equals to 2. Alright, just notice at the start it said when x is between 8 and 1. So for example, in the question you get an x answer of x equals to 15. So automatically you know that this answer is incorrect because there was a restriction. So x has to be between 1 and 8. 6 and 2 are both in between 1 and 8, so therefore you know you're on the right track. However, if you get an x value of higher than 8, for example, like I said, x equals to 15, you know you've done something wrong, and that means you have to go back and check your steps again. So that's why I said to note down that x is between 1 and 8, because that can really help you if you make a mistake. Just something to note down, okay? It's not life-changing important, but if you do make a mistake, okay, it's good to check with the boundaries given. Sorry, moving back to the question, we have x equals to 6 or x equals to 2. Once again, we don't know which one is the maximum and which one is the minimum. Therefore, we need to use our second derivative test to prove which one is the minimum. So therefore, we're going to find our p double dash of x, the second derivative, and that will give us 6x minus 24. If we substitute 6 in, so p double dash of 6, that will give us 36 minus 24. This is positive, so therefore this is a minimum, which is what we want. However, we're just going to do the other one as well. So p that, it's good to do the other one just to check, and once again, it's just the same checking, just to be sure. So for example, you do both and they're both positive, once again, you know you've done something wrong. However, if you just do one and then you just ignore the rest, there's a possibility you might have done it wrong and you just don't know. So it's good to double check everything. So just do that. P double dash of 2, that equals to 12 minus 24. This is equal to negative 12. This is a negative, so therefore this is our maximum. Okay? So now we found our minimum, and we're going to substitute this minimum back into our original function to find our profit. Okay? So therefore, we're going to substitute p of 6, and that equals to x cubed, so 6 cubed minus 12 of 6 squared plus 36 of 6 plus of 3. Alright, so we're just going to check our answer. Just use our calculator. 6 to the power 3 minus so you should get your answer as equals to 3. However, that's not your final answer. Your final answer, so the daily profit in thousands of dollars. That's so important to note, okay? It says in thousands of dollars, and you give your answer as 3, you'll get marked down, okay? You don't want to get marked down, so therefore you'll leave your final answer as $3,000. So therefore you'll leave your answer as $3,000 as the minimum as your final answer. Just be very careful with the wording of the question. Alright, so for the next question, I'm going to be covering one last example of a maximum and minimum question. Roll it. Hey guys, welcome back to one final example for a maximum and minimum question with an application type question. So a courier firm has a restriction on the size of parcels they will carry at a normal rate. The sum of the length, width, of height of any parcel must be less than 162 centimeters. The length of a box is twice its width. Find the maximum possible volume of the parcel that be carried at a normal rate. Okay, so for this question, we need to find, so you know that volume. So volume equals to base times height times length. Alright, we're going to call this width, sorry. Alright, so right now we can't actually differentiate because we have 3 different variables. We want to make all 3 of these variables in terms of just one variable. So we'll just say that since the length of the parcel is twice its width, we'll say that width is equal to x, so therefore our length will be equal to 2x, double our width. So therefore our length, we can say, is 2x, while our width is just x. Alright, so you notice that the total of all the lengths and heights and width must be equal to 162 centimeters. So therefore our height would equal to 162 minus 3x, minus these two added together, and that will give us our height. So now we can rewrite our volume formula. So we can say that V equals to 162 minus 3x times of 2x times of x. So therefore, we'll get 162 minus 3x multiplied by 2x squared. And that should give us, just calculator here. Should give us 324x squared minus 6x cubed. And that equals to our volume. So therefore, now we have our volume formula. We need to differentiate, and to find the maximum, we need to differentiate, and then we need to make equal to 0. So v dash of x that equals to 648x minus 18x squared. And now we need to make equal to 0. So 0 equals to 648x minus 18x squared. So if you take the you can take the 18 out. So 0 equals to 18x times of 36 minus x. So therefore x equals to 0 or x equals to 36. Let me double check that. Yep. So x was 0, x was 36. But notice that your x can't actually be 0 because you can't actually have a 0 width and 0 length, okay? So therefore we can automatically just eliminate this. I mean, you can use the second derivative test, but for this specific question, it doesn't ask you to prove it. So therefore we can just eliminate the x equals to 0 automatically and then say it's 36. So now we'll substitute everything in. So v equals to 162 minus 3 times of 36 times of 72 times of 36. So 162 minus 36. Okay, so times 74 times 36. You should get your answer should come out to be as 143,856. Oh, was it in centimeters? Yes, it was in centimeters. So centimeters cubed. And that should be your final answer. Just let me double check. Yeah, that should be your final answer there. And that's 2 examples on how to solve a maximum and minimum question given an application situation. For the next clip, I'll be doing a simple integration. Roll it. Alright, so question 2. Sorry, I won't do my question. What am I saying? So welcome back. Okay, so it's a gradient function. So this time we're going from a gradient function to a function. And we're going to integrate and substitute the point in to find our function. So we need to integrate. So it's basically we're doing the opposite, so anti-differentiation. So therefore, we're going to find out f of x. That equals to the integral of 8x to the power 3 minus 5 dx. Therefore, f of x equals to, you add 1 to the power and you divide by the new power. 2x to the power 4 minus 5x plus of c. Now you substitute the point 1, 4. So when y equals to 4, x equals to 1. 4 equals to 2, 1 to the power 4 minus 5 plus c. And if you solve the equation, you should get c equals to 7. Therefore, f of x equals to 2x to the power 4 minus 5x plus of 7. Alright, so for the next clip, we're going to be drawing a gradient function. Roll it. Alright, now we're going to be sketching the gradient function when given the f of x. So basically, we're going from cubic to parabola. How are we going to do that? Okay, so basically, as you can see, we need to identify our turning points. Turning point, turning point. Okay, so you know you're going to be sketching a gradient function. And you know that when at a turning point, the gradient equals to 0. So at the turning points, gradient equals to 0. So you know that at the turning points of the cubic is where your x-intercepts of your parabola will be. So that's the first thing you're going to mark down. So this is x equals to -2, and this is x equals to 4. So that are going to be your x-intercepts for your parabola, because that's when your gradient is going to be equal to 0, because that's the turning point of the cubic. So going down, we're going to be marking these points. So x equals to -2 and equals to 4. Alright, so next thing we're going to be noticing is our genuine shape of our cubic. Alright, so as you can see, this is a positive cubic. Okay, so positive cubic translates to a positive parabola. So that means our parabola will also be sorry, what am I saying? So therefore, our parabola will also be a positive parabola. So because it says sketch the gradient function, we don't need to be precise. So therefore, we just need to draw a rough sketch. So as you can see, when x is less than -2, so if I look to x is less than -2, as you can see, the graph is increasing. That means the gradient is bigger than 0. But after x equals to -2, the gradient starts going down. So therefore, this is when the gradient is less than 0. And after x equals to 4, so when m is greater than 4, the gradient, when x is greater than 4, that's when our m is greater than 0 once again, because it's sloping upwards. So how's this going to work out? Okay, so basically, when x is less than -2, our gradient is going to be positive, so it's going to be something here. We'll just say here. After x equals to -2, okay, our gradient is going to become negative, so it's going to go, it's going to draw this. Alright, so it's just going to draw a genuine shape for a parabola. So basically, it's just going to be a shape of a positive parabola here. So it's just going to look something like... Yeah, it's not a very good drawing. Let me try that again. Alright, so that's something that's about what you would be looking for in the exam. But in the exam, you're going to be drawing a lot better than this. It's just a rough sketch. But that should be the approximate shape of your parabola. And that should be what you're looking for. Alright, so for the next clip, we're going to be looking how to go the opposite way. So from a gradient function back to a function. Roll it. Alright, so in this clip, we're going to be covering... In this clip, we're going to be covering how to go the opposite way. So from a gradient function back to a function. As you can see, we have a linear graph right now. First thing to notice about the linear graph is whether it's a positive or a negative gradient. As you can see, as x increases, the y value decreases. So this is a negative shape. So therefore, when we go back to our parabola is also going to be a negative parabola. Alright. First thing to note down in these questions, okay, you need to note down the x-intercept. So the x-intercept of the gradient function is x equals to 4. That means when x equals to 4, the gradient was equal to 0. And when a gradient is 0, as we established this before, when a gradient is equal to 0, that can only mean one thing. That's the turning point of the parabola, or aka our vertex. So we already know the shape of our parabola. Our shape of the parabola, as you can see, this is a negative straight line. So we're going to get a negative cubic. Negative parabola. So our parabola is going to be in the shape of something like this. And it's going to have a turning point when x equals to 4. One more thing to keep in consideration is that the maximum value of h is 5. So the maximum is y equals to 5. So this point has to go through 4, 5. That's what it's saying. Because at the maximum, so this is a positive, this is a negative parabola. So therefore, at x equals to 4 is our turning point. And since there's only one turning point, this has to be a maximum. And therefore, it has to pass through the point 4, 5. So now we're going to come back down to our grid. We're going to pull out the point 4, 5. So our parabola has to pass through this point here. And the rest can just be a rough sketch. So as you can see, this is a negative line. So we're going to draw our negative parabola with the point passing through 4, 5. So it might just look something like this. And that's what you're looking for in the exam, okay? So it says to label your vertex clearly. So you can say, this is the vertex, and it passes through the point 4, 5. And this is our vertex. And that's really all you need to do, okay? So basically identify the x-intercept, and from there you're going to be working out where your turning point is. In the next video, I'm going to be going from a parabola to a cubic. Roll it. Alright, welcome back. So I'm going to go from a parabola to a cubic this time. Once again, the first step is to note down our intercepts, okay? Our intercepts is at x equals to -4. Well, not necessarily x equals to -4, but it's just a fourth space to the left. And we also have x equals to a. So it's important to note these down, is because these are when the gradient equals to 0. And if the gradient equals to 0, that's where our turning points will be. So we're going to come back down to our graph, and we're going to mark these points. So Those 2 points are where our turning points are going to be. Alright, so another important note to note down is that when h of a equals 0, so h of a equals 0, that means when h equals to a, y equals to 0. So therefore, it's going to pass through the point of a0. So it's going to pass through this point. Also notice that it's a turning point, so that it's going to be at where our minimum turning point will be. Alright, it's important to note down the shape. It's a positive parabola, so it's going to give us a positive cubic. It doesn't really matter where the turning points are in terms of the y points, but it has to pass through it has to be directed above the correct above or below the correct x points. So we're just gonna draw a graph, okay? It's gonna look something like this. It's gonna go up. It's gonna have a turning point at the fourth point to the left, and it's gonna come right back down. Terrible. It's gonna start coming back down. And it's going to pass through the point of a0, and it's going to come back up again. And there's our cubic, okay? So basically just getting the turning points correct, okay, in terms of the x values, and passing through the correct points. Alright, in the next video, I'm going to be looking a little bit back into kinematics. I'm going to look into some kinematics. Roll it. Alright, so now we're going to be looking at some kinematics. I don't have time to cover everything, but I'm going to cover some 3 or 4 main questions, okay? So just basically getting the idea for kinematics. So the thing we want to note down is I am very sexy. Okay, so basically I stands for integrate. So you integrate from acceleration to velocity to distance, and then you differentiate the opposite way. Alright, so that's basically the main strategy you need to use in kinematics, and all the other skills you should already have, so differentiation and integration. Alright, so for example, this question right here, they're playing with a wind-up toy. The velocity can be modeled by this equation, where t is the time in seconds. After 10 seconds, the train is 15 centimeters away from Meg. 15 centimeters is a distance, so you automatically know it has to be something related to distance. So how far was the train from Meg at the start? Okay, so basically we're gonna integrate. So from v to s is integration, so s of t equals to 60t minus t cubed. So basically add 1 to the power divided by the new power plus c. After 10 seconds, the train is 15 centimeters away from Meg. So when t equals to 10, s equals to 15. Okay, so 15 equals to 60 times of 10 minus 1,000 plus c. And that should give us the answer. Six. So therefore c equals to 415 centimeters. So basically the c value, what the c value really stands for is what the object initially had. For example, I say v equals to 3t plus 2, for example. So when t equals 0, then our v would equal to 2. So therefore, originally at the start, we already had a velocity. So basically, what was the thing at the start? So therefore, when we see our c value equals to 415 centimeters, we can say our train was 415 centimeters away. Yeah, that's just something we can say. Alright, for the next question, I'm going to be covering another example. Roll it. Yeah, hey guys, actually I don't have much time, so unfortunately I won't be able to do as much kinematics as I originally hoped I would. But I'm just going to do one final little clip on explaining basically explaining exactly what it works, okay? So basically, once again, I say you have the a, v, s, okay? You integrate from a to v and v to s, and you differentiate from s to v and v to a. So basically, when a question asks you something, gives you an acceleration, and wants you to find like a velocity in a given time, so you automatically know you have to integrate, and you have to add the plus c. So, as I stated before, the plus c is basically what you originally had. So for example, what you started off with. So basically, if the question doesn't specify what for example, what it started off with, then you can just safely assume that c equals to 0. However, if the question says something like this, for example, the question might say, at the start of the flight, the whatever had a speed of 2 meters per second. So at the start, so that's when t equals to 0, the speed was 2. So therefore, you can know your c equals to 2 as well. So basically, just using what the question tells you. And they tell you to find a maximum or minimum. Once again, that's using the exact same principle. So for example, you have a velocity equals to, for example, 3t squared. And it wants you to find 3t squared plus 3 plus 3t. And it wants you to find for example, the maximum. So once again, that's the exact same logic. So you find the derivative, that equals to 6t plus 3. And therefore, make it equal to 0. So make it equal to 0, so 0 equals to 6t plus 3. Therefore, t equals to negative 0.5. Okay, this actually isn't, no, it's not. Yeah, it's negative 0.5. Well, technically, in this situation, it's not possible, but you get what I mean. So basically, after you found your t equals to whatever, you'll substitute that t back into your velocity formula. And that's really the same for anything. For example, the same for the distance, same for everything else. So for example, maybe it will ask you, how much has this thing traveled when the velocity is at a maximum? So instead of substituting your maximum t back into the velocity formula, you'll substitute that t back into the distance formula. Alright, so once again, I apologize for not having enough time to do a few more examples, but I hope this little clip has given you some idea of how kinematics works, okay? So I apologize once again, but unfortunately, that's life. So I hope you enjoyed watching this little added up clip of what you need to know, and I hope to see you all in the next one. Thank you, bye.